exam 4. Uh, 29 through 38. And number 30, it says the particle has a position of t to the 4th minus 10t cubed plus 29t squared minus 36t plus 2. So we got a position function given, and it says it's moving along the x-axis, so that its position is given by the following. Got time greater than 0, and the question is for which of the following values is the speed the greatest? Okay. So ultimately, if we know that speed is the absolute value of the velocity, if we could find the velocity function for this, we'd have 4t cubed minus 30t squared plus 29t minus 36. True. And if we want to find out which one of those is the speed the greatest, I would put that in my y equals if I were you.
Isn't that 58t?
You're right, thanks. Yep. And so I'd have 4t cubed minus 30t squared plus 58t minus 36. And then if I were you, I'd just do, I get my table on ask, I'd just put it on ask and start looking. You got 1, your velocity is negative 4, 2, 3, 4, and 5. So again, the question is which one of these is the speed the greatest? And if you put time 5 because it's the positive one, that's not going to be right because that's not where the speed is the greatest. Okay? Because the speed is the absolute value of these, so where is the speed the greatest? It'd be at time 4. What else? Up through 33. Yeah. 32, we got let f be the function where f of 3 is negative 6. F prime at 3 is 4. Let g be defined by the function 4x plus f of x over x for all x not equal to 0. And it says which of the following could be an equation for the line tangent to the graph of g at the point where x equals 3. So ultimately we need to find the, if we're going to find the equation for the tangent line of g, we need to know the slope of g at that point. So if we do the derivative of g, we're going to get 4 here. And then we've got to recognize here we have what rule? That's quotient. So we'd have x times f prime minus f prime times 1 all over x squared. So that would be our derivative of g, and we want g at 3. So we'd have 4 plus 3 times f prime at 3 minus f of 3 all over 3 squared, which would be 9 down here. And if we fill in the blanks, f prime at 3 is what?
4.
F prime at 3 is 4, so we'd have 3 times 4 here, minus, and f of 3 is negative 6, it says. So we get 12 plus 6, that's 18. 18 divided by 9 is 2, so we get our answer of 6. And then from there, if we want to fill in our blanks on the point slope form, we need to find a point here. And again, we know the x value is 3 here. We just need to know g of 3. Well, g of 3 we can find from our g function here. We'd have 12. And then f of 3 we said was negative 6. So negative 6 over 3 would be negative 2. 12 plus negative 2, negative 10. And the whoops, what do I have positive? Did I say that? No, this is positive here. This was positive 12, right? Yeah, 12. We got negative 2, so it's minus. So positive 10, not negative 10. So we got y minus 10 then for this. 6 times x minus 3 looks like that corresponds with e. Questions on any of the steps on that one? What else? 33. 33, we got says let f of t be defined as 0 to t of e to the x cosine x times cosine x minus x sine x. And on 0 to 10, and it says at which of the following values does does f attain its absolute maximum value? All right. So ultimately here, we're looking at for which value of t, and being that it's a closed interval here from 0 to 10, including 0 and 10. 0 and 10 could be options, but since it's multiple choice, we can see that 0 and 10 are not options, in fact. True. So bottom line is if the endpoints aren't options, then the only other options are going to be when the derivative equals 0, or when the derivative doesn't exist. So what is the derivative of f here? It's just the integrand evaluated at the upper limit. Cody, you got your information to give to Ms. Johnson in the office. Sure. For the top 10.
Oh. I can get it to him later.
Later today, is that okay? Okay. Okay, thanks. Alright, so ultimately the integrand evaluated at the upper limit, and ultimately how much time we're going to spend on the algebra finding the zeros of this? None. It's a calculator problem. So, put it in the calculator. So we got e to the x cosine x times cosine x minus x sine x. And our interval here is what? 0 to 10? Alright, so we can see some zeros here. I'm going to change my Y window to make it see those a little bit better. Again, keep in mind we're looking at a picture of the derivative here, so the derivative goes from positive to negative here. So that means that that one right there should represent a what? Should be a maximum. Right, this one goes from negative to positive, so that should be a minimum. And this one goes from positive to negative, which would be a maximum again. And this one looks like it, hard to tell if it crosses the x-axis again there or not. We can zoom in on that if we want to. But bottom line here is that, that this point is a candidate. So if we do our 0 command, what's that? Are we looking for a maximum? Oh, we are looking for a maximum. Never mind. All right, I read it wrong. So I thought we were after a minimum. So let's try that again. So we do want a maximum. So that first one is our first candidate. So let's check it out. So we got one candidate would be that 0.8603359. Do that again with the other candidate, which is over here. Without doing all this work, we probably can answer this question without having to do this. Whoops, I passed it. Whoops. There we are. Alright, and again, using our x's and y's, we're to the left of it right now because we're above it, so now we're below it. So 6.4372982. Alright, and if we had to take a wild guess at this point, which one's going to give us the bigger value? Should be this one. I mean, look how much more area we accumulated in this area than we did in this little area. And we accumulate a little bit of positive area, basically negate it with this, and then some, right? We're a little bit negative here at this point, and then we get quite a bit of positive area here. True? So it should occur at this one where the absolute maximum is. it should correspond with letter C. And again, if you want to, you can put both of those into the actual function and find the y values and see that the y value at the 6 is bigger than the one at 0.86. Like I said, for time's sake on the test, I would recognize that there's a lot more area in the second one than there would be in the first one. Anything else in that group, 29 through 33? Second group, 34 to 38.
34.
34, we got a particle with a velocity given 2e to the 2t. This is how far does the particle travel during the time interval when its velocity increases from 2 to 4. So ultimately we need to find that time interval first. So when the velocity is 2, what time would it be? Well, if we divide here, we're going to get 1 equals e to the 2t. Natural log both sides, you get natural log of 1 equals 2t. Natural log of 1 is 0, so it would be times 0 would be the first time in question. If we let that be 4, we get 2 over here equals e to the 2t. Get ln 2 over here equals 2t. That'll be 1/2 ln 2 equals t. So those would be the two time frames. And again, this calculator problem, so you could theoretically solve these with a calculator and get, use all the decimals if you do it that way, I guess. Ultimately, these are easy to solve, probably quicker to solve it by hand than it is by typing all that in the calculator. But bottom line is we know how far does it travel, so we need the absolute value of 2e to the 2t dt on 0 to 1/2 ln 2. That would give us the total distance traveled, wouldn't it? Do we really need the absolute values in this case? If not, why not? What do we know about 2e to the 2t? It's always positive, so I don't really need them, but do it anyway. So bottom line is, again, don't spend any time on the algebra of that or the calculus, just use your calculator. So 2e to the 2x and looks like it turns out to be 1. Correspond with letter A. What else?
38.
On number 38, says the find the slope of the function f of x equals 0 to x arc sine, which we know is sine inverse of t dt, and it says find the slope when x is equal to 0.4. So ultimately the slope is going to be the derivative, of course. So the derivative here is just going to be sine inverse x. So we just want sine inverse x at 0.4. So let's calculate a problem again. 0.411, 412 that is. Letter C. So again, what are they testing you on there? Pretty sure that'd be in this class you can use your calculator, but that's a fundamental theorem, isn't it? Find the derivative of an integral function, integrand evaluated at the upper limit. What else? Good. 36. 2 cars traveling. Looks like a related rates problem right off the bat, right? So we got 2 cars start at the same place, same time. One car travels west at a constant velocity of 50 miles per hour. So going this way, and we'll call it x. The second car travels south. We'll call that y. So approximately how fast is the distance between them changing a half hour later? So that would be z. So all changing quantities. And so for us, we know that dx dt is the velocity of the first car, which is 50. And we know dy dt is the velocity of the second car, which is 60. And we ultimately want to know dz dt. So what equation relates these 3 variables? Just Pythagorean theorem. So x squared plus y squared equals z squared. We know that 2x dx dt plus 2y dy dt is going to equul 2z dz dt. Cram that all in there in that space. Alright, so bottom line here is let's see if we can fill in the blanks. Well, we know that 50 and 60 are dy dt and dx dt. Okay. And then what about the x and y here? So is that the instant when it's a half hour later? So half hour later, how far has the x car traveled in a half hour? 25. So it'll be 2 times 25 for that one. This one would be 2 times 30. Half hour went 30 miles. And then on the other side, 2 times z times dz dt. We're ultimately looking for dz dt, so the only blank we need is that one. Okay, ultimately, if I know that this is 25 and that's 30, I can find z at that instant too, can I? So 25 squared plus 30 squared. And square root of that would be that. And we can just leave it as that. So that right there is 39.051, if you will. Bottom line is 2 times that is going to have to get divided into this stuff on this side. So let's go ahead and get our answer for the left side. If we get our answer for the left side, we're going to get 50 times 50. 50 times 50 is 2,500. And then these two would be 1,800 times 2 would be 3,600. So 36 and 25 make 51. 61. So, and then we're going to divide that by 2 times our answer. 78 point. And it says approximately. So 78.1, approximate choice would be letter D would be the best choice. Alright, so again, same general strategy in any related rates problems. Okay, draw a picture, identify what derivatives you know, okay. List any changing quantities, any non-changing quantities if there are any. Write an equation that relates the variables. Differentiate the equation with respect to time. Plug in all your instances. Solve for the missing part. What else? Alrighty, 35. So we're given a derivative again here. So we got the derivative function is x over 15 plus sine of e to the point 2x. So is how many relative maximum points does it have in the interval 0 through 12? Well, again, we're going to have relative maximums when this derivative either doesn't exist or where it equals 0, right? So not try to set that equal to 0 and solve it with algebra. It's on the calculator part again. So we got x over 15 plus sine of e to the point 2x. And we're going 0 to 12 on the window here. So let's see what we see here. Alright, so bottom line is it looks like we have how many zeros? Looks like we have 3 zeros. And again, we want to know how many relative maximums. Okay. Well, the derivative here goes from positive to negative, so that should be maximum, right? Derivative here goes from negative to positive, so that would be minimum. Positive to negative again here. So another maximum. So therefore, how many maximums should this function have? 2. Questions on that one? Anything else on the calculator part 1 through 29 through 38?